Hi everyone, in today's lesson I'm going to show you a method of integration using U substitution. So if you look at the problem here, number 1, it says they want you to evaluate the integral of this function dx. Now it'd be helpful to know that everything in front of the dx, like this, is what we are trying to integrate. The parentheses just won't always be there. So same thing in like problem number 2, I want to find the integration or evaluate the antiderivative of all of that. Same thing here for number 3, and same thing here for number 4. So the first thing that I want to do is recognize that solving this integral might not be as easy as we would like, because you see how I have all of this being raised to the 4th power? I would technically have to quadruple distribute all of that stuff out before I can continue to take the integral. So there's a method called U substitution, which helps us solve for things that are a little bit more complicated. So I'm going to write down the steps as we go. So the first step is going to be to let U equal the stuff that's inside the parentheses. So step 1, let U equal, I'm just going to put parentheses. So U, in this case, is going to be 2x squared plus 3. We're letting U equal the stuff that's inside the parentheses. Then, step 2 is we're going to take the derivative. So step 2, find du, which in other words is the derivative. Okay, so du is the derivative. So if I'm starting with u, I'm ending with du. That is my derivative. So du is equal to 4x, right? Because the derivative of 2x squared is 2 times 2, which is 4. Drop the power down by 1. And then the derivative of a constant is 0, so I don't have to put anything there. But now the trick with this, after we take the derivative, we have to write dx next to it, because that tells us that we're taking the derivative with respect to x. And now step 3 will be to solve this equation above. So solve for dx. Okay, so the question you want to ask yourselves is, how is this 4x and dx connected to each other? Well, they're connected via multiplication. So if it'll help you, put a multiplication dot in there. And the goal is to solve for dx. So I'm just going to rewrite it. If I have du is equal to 4x times dx, to solve for dx, I'm going to divide both sides by 4x. So I get that dx, I'm just going to write it on the other side, dx is du over 4x. So once I do those 3 steps, I pretty much can solve the problem. So I'm going to put in here the 2x squared plus 3 is what I let u equal. So when I want to take the integral, it's going to be of u to the 4th. And then times this 4x right here is not changing, so times 4x. But now we can actually substitute this dx part. We just solved down here that dx is du over 4x. So I'm replacing each piece. This part is u, so u to the 4th, 4x stays, and then this dx is what I equaled it to, would be du over 4x. So these cancel now. So you see how now I've simplified it, and these top 4x with this bottom 4x is going to cancel. So I'm really taking the integral of u to the 4th with du next to it. So you see how I kind of changed an integration problem with respect to x's with respect to u's? That's the idea. The idea is that I took something extremely complicated with x's and I made it something very simple to integrate. We know how to integrate a polynomial. This is nothing more than a polynomial. So if I'm asking you to integrate u to the 4th, we add 1 to the power and then divide by that power. So this is simply u to the 5th over 5 plus c. And to get our final answer in terms of x, we're just going to put our x back in. So what did I let u equal? Well, this is what u is, right? U is 2x plus 3, 2x squared plus 3. So for this u right here, I'm going to put 2x squared plus 3. So the final answer is 2x squared. Whoops, wrong one, sorry. 2x squared plus 3 to the 5th power over 5 plus c. And that's it. That's the final answer. All right, let's try a little bit more of a complicated problem. Let's look at number 2. So in problem number 2, same concept. Nobody wants to sit here and do this whole thing, this 5x to the 3rd minus 3 to the 4th power. So nobody wants to do that. So again, we're going to follow steps. Step 1, we're going to let u equal what's inside the parentheses. So u is going to be equal to 5x to the 3rd minus 3. Then we're going to take the derivative, step 2, du. So the derivative of 5x to the 3rd is nothing other than 15x squared dx, because we took the derivative with respect to x. Remember, those two things are being multiplied together, and we have to solve for dx. So we're going to divide by 15x squared, both sides. So again, I'm going to switch the sides. So I'm going to say dx is equal to du over 15x squared. Okay, so now let's go back to our integration and plug everything back in. So we have this 45x squared. That's not changing. This 5x to the 3rd minus 3 is my u, so I'm going to change that to u. And we're going to raise that to the 4th power. You know what? I see that I have parentheses there. It's not really necessary. Same thing as multiplying, so I'm just going to make it multiplication dot of u to the 4th. dx, again, we're multiplying. This is what dx is equal to. So dx is du over 15x squared. So just to reiterate what I did, I put this in for u, and this is for dx, right, from down here. So now, if you notice, in this particular problem in example 1, these 4x's canceled, but in this one, these don't. I mean, the x squareds will definitely cancel, right? This top x squared with this bottom x squared will cancel. But I can't cancel out the 45 and 15. But I actually can divide those. So 45 divided by 15 is nothing other than 3. So I want to integrate 3, u to the 4th du. So again, we have those polynomial rules. Add 1 and divide by that power. So when we take the antiderivative, it's nothing other than 3u to the 5th over 5 plus c. And again, to get our final answer, all we're going to do is we're going to take what we let u equal, which is this piece, and put it back in for this u. So we have our answer in terms of x. So we've got 3, 5x to the 3rd minus 3 over 5 plus c. That's your final answer. All right, at this point, I'd like to move on to questions 3 and 4. I do believe that you can do these two on your own. So what I'd actually like you to do now is pause the video, copy these two problems down, and try it on your own, and then hit resume for the answers. No cheating. Okay, here are your answers. Okay, so just a few things that I want you to look out for. When you add 1 to a negative number, so if you look over here, like here it says -5. When you add 1 to that, you get a -4. It becomes smaller and closer to 0. Same thing over here. When you add 1 to the -3, you get -2. So I just wanted to point that out. All right, let's move on to example 5 and 6. So same thing for example number 5. We're still going to let u equal the more complicated section, or what's inside the parentheses. So I think what I'm going to do is I'm going to set them up for you. So I'll set up 5 and I'll also set up 7, and you can try the remainder on your own. So for number 5, again, when we set it up, we're going to set up what's inside the parentheses. So we're going to let u equal the 2x to the third minus 3. And then we're going to say du, take the derivative. Du is 6x squared dx. And then again, solve for dx. So dx is equal to du over 6x squared. So all we want to do now is same thing as before. Keep the 6x squared. This is what I let u equal, so times u to the 3 halves. And then plug in dx. Dx is du over 6x squared. And nice and easy, these 6x squareds cancel. So we're left with the integration of u to the 3 halves du. And again, when I integrate a fraction, we want to add 1 to the power. So what that means is 3 halves plus 2 halves, which is 1, is 5 halves. So it becomes u to the 5 halves divided by 5 halves, which is the same thing as multiplying by the reciprocal. So I'm going to multiply by 2/5 and then plus c. So my final answer should be 2u, which is 2x to the third minus 3 to the 5 halves, all over 5 plus c. Now, you have a choice. You could put this all over 5, or you could have written it as 2/5 parentheses to the 5/3. Same concept, but you probably will see it as a multiple choice this way. All right, I'm going to leave number 6 as extra practice, so you guys can try that one on your own if you'd like. And I'm going to move on to question number 7. So question number 7, same kind of concept. We're going to let this part equal u, what's inside the parentheses. So u is going to be equal to 2x to the 4th minus 5. And then I'm going to find du. The derivative of u in this case will be 8x to the 3rd dx. And again, same thing like we've been doing before, solve the equation for dx. Okay, so pause the video to catch up to the work that I just did, and then hit resume when you're ready to move on. All right, so same concept. The 24x to the 3rd stays. The u this time is now on the bottom, so u to the 4th dx. So in this problem, when we solve for the dx now, or when we substitute, actually, I think I'm going to do that. So let's substitute the dx now this way. This is going to be du over 8x to the 3rd. So it just looks a little different than the rest, but these x to the 3rds can cancel, and the 24 divided by 8 is a 3 over 1 to be exact, so that's going to go in the numerator. So it's 3 over u to the 4th du. Now, before we integrate this, it's probably easier if we take this denominator and bring it upstairs. So let's make this 3u to the negative 4 du. Now I think it's much easier to solve. So we're going to make this 3u to the negative 3, add 1 to the power, divide by that number, and then plus c. So what's nice is that these 3 cancel, and we're left with just negative 1 on the bottom. So this is really negative u to the negative 3rd plus c. And then go ahead and substitute what we let x equal, u. So 2x to the 4th minus 5 to the negative 3 power plus c. So that is your final answer. Now, the last one that I'd like to go over is a problem like number 9. So number 9 is going to have the same concept as all the rest did, except before I can take the integration, I want to write it as a 1/2 power. So I'm going to integrate 4x times 2x squared plus 5 to the 1/2 power. So this is now my u. So u is equal to 2x squared plus 5, and du is 4x dx. And then just solve for dx by dividing by 4x. And then substitute our numbers back in. Oh, this one needs to be a dx here. So again, pause the video, catch up to what I had, but again, the concepts are still going to be the same, and then hit resume when you're ready. All right, so now it's time to plug in. We have 4x times u to the 1/2 times dx, which is du over 4x. 4x's cancel, and I want to integrate u to the 1/2 du. So add 1 to the power. 1/2 plus 2/2 is 3/2. So it's u to the 3/2 divided by 3/2, which is the same thing as multiplying by 2/3, and then plus c. And last but not least, our final answer is to substitute what we let u equal. So 2, oops, I'll write with the highlighter, 2/3 u, which is 2x squared plus 5 to the 3/2 plus c. This would be your final answer. As I did in the previous example, if you had wanted to, you could write this as 2 times 2x squared plus 5 to the 3/2 over all over 3 plus c. So both of these are kind of acceptable answers. I think I prefer this one, but really the choice is yours. Okay, that's it for today.